Hello everyone. In this video, I will discuss about the how to solve the linear program for minimization of the objective function by graphical method of extreme or corner approach method. Let's see the problem. Use the graphical method to solve the following linear programming problem. Minimize z equal to minus x1 plus 2x2 subject to constraint minus x1 plus 3x2 less than or equal to 10, x1 plus x2 less than or equal to 6, x1 minus x2 less than or equal to 2, and x1 comma x2 are greater than or equal to 0. Here, minimize z equal to minus x1 plus 2x2 is the objective function, and x1 comma x2 are the decision variables, and these are the constraints. Let's see the solution. First step is consider the each inequality constraint as an equation. For this, replace the inequality symbol by equality symbol in constraints, and these are our constraint equations. Next step is each constraint will be plotted on the graph by treating it as a linear equation. For this, first we have to determine the coordinates for the each constraint equation. First constraint equation is minus x1 plus 3x2 equal to 10, and assume x2 equal to 0 and substitute in the above equation. Then we will get the x1 value is the minus 10. Similarly, assume x1 equal to 0 and substitute in the above equation. Then we will get the x2 value is the 10 by 3, and coordinates for the first constraint equation is minus 10 comma 10 by 3. Next constraint equation is x1 plus x2 equal to 6. Here assume x2 equal to 0 and substitute in the above equation. Then we will get x1 equal to 6. Similarly, assume x1 equal to 0 and substitute in the above equation. We will get the x2 value is the 6, and coordinates for the second constraint equation is 6 comma 6. Next third constraint is x1 minus x2 equal to 2, and assume x1 equal to 0 and substitute in the above equation. Then we will get the x2 value is the minus 2. Similarly, assume x2 equal to 0 and substitute in the above equation. We will get the x1 value is 2. Then coordinates for the third constraint equation is 2 comma minus 2. Next we have to plot the constraints on the graph. For this, draw a horizontal and vertical axis on the graph sheet. Here x1 as the horizontal axis and x2 as the vertical axis. Next, observe the coordinates values for the x1 and x2. Here highest two numbers are 10 for the x1 and 6 for x2. So make the 10 divisions on x1 and x2 axis at both of the positive and negative sides. Here 1 centimeter equal to 1 unit. So first we have to mark the coordinates for the first constraint equation, that is minus 10 comma 10 by 3. So mark minus 10 on x1 axis and 10 by 3, that is 3.33 on x2 axis. And to join these 2 points, we will get the line for the first constraint equation. And we have to extend this line at a positive side. So why we have to extend this line means x1 and x2 are greater than or equal to 0. Next, mark the 6 comma 6 on x1 and x2 axis. And join these points, we will get the line for the second constraint equation. So next we have to mark the 2 comma minus 2 on x1 and x2 axis, and to join these points, and we have to extend at positive side, we will get the third constraint line. Next step is mark the feasible region based on inequality conditions of the constraints. So first to mark the region for each constraint. For this, remember two conditions. First condition is if the coefficients of the decision variables are positive in the constraint equation, then mark the region based on inequality symbol. If the greater than or equal to inequality symbol, we have to consider the region above the line. If the inequality symbol less than or equal to, then we have to consider the region below the line. Second condition is if the coefficients of the decision variables are negative in the constraint equation, then we have to mark the region based on x1 coordinate value. If the x1 coordinate value is the positive, then we have to consider the region above the line. If the x1 coordinate value is the negative, then we have to consider the region below the line. So first we have to observe the coefficients for the first constraint. Here x1 coefficient is the negative, so second condition is satisfying. And x1 coordinate is negative, then we have to consider the region below the line. So here we have to consider the region below the line. So next for the second constraints, here we have to observe the coefficients for the x1 and x2. Both are having the positive only. So first condition is satisfying. So then we have to mark the region based on the inequality. Here we are having the less than or equal to inequality. So we have to mark the region below the line. So next we have to go for the third constraint. Here observe that one, x2 coefficient is the negative. So second condition is satisfying and x1 coefficient is the positive. So we have to mark the region above the line. Next to mark the feasible region, which means the area which is bounded by all the constraint lines. This is nothing but common area for all the constraints region. Here OA BCD is the feasible region and coordinates are the 0, 0 for O and 2, 0 for A and 4, 2 for B and 2, 4 for the C and 0 and 10/3 for the D. Next step is evaluate the objective function at each extreme point of the feasible region. For this, draw a tabular column. First column is having the extreme points, that is OA, BC, D, and second column having the respective coordinates values of the each extreme points. Third column is objective function value. For this, substitute x1 and x2 values for each extreme point. So here, first extreme point is O and coordinates are 0, 0. And we have to substitute these coordinates values in the objective function. Then z equal to 0. Next we have to substitute the A point's coordinates, that is 2, 0 in the objective function. Then we will get the z value is the -2. Next we have to substitute the B point's coordinates, that is 4, 2 in the objective function. Then we will get the z equal to 0. So next we have to substitute the C point coordinates, that is 2, 4 in the objective function. Then we will get the z equal to 6. And finally we have to substitute the D points coordinates, that is 0, 10 by 3. And we have to substitute these coordinates values in the objective function. Then we will get the z value is the 20 by 3. Here we have to observe that one, among these z values, z equal to -2 is the minimum at extreme point of A. So optimal solution is x1 equal to 2 and x2 equal to 0. And the minimum value of the z is -2. So this is the solution, and thank you.